Hi again. In the previous video, I underestimated how long it would take me to go over Hess's law. I didn't have time to do the problems that I wanted to try. Why don't we do that here? We're going to do two problems. They're examples of test problems I've used in the past. And here they are. Okay. This video is no longer G50, it's now G60. And we are doing two example test problems that uses Hess's law. You've seen the previous video, I assume, so why don't you take this opportunity to try these problems under test conditions. The first one is pretty easy. The second one is amazingly, at least for me, difficult. Once you're done with the problems, go ahead and come back to the video, and I'll show you how I would do both of them. For me, I want to keep things as organized as possible. I'm going to label these given reactions A and B, and I'm going to label this one, oh, it's the target. The trick is to focus on the compounds that occur in only one of the individual steps. It looks pretty straightforward because we have a P4O6 and a P4O10. We have those as part of the target. For A prime meaning that after manipulation, I am going to copy it exactly because I have a coefficient of 1 for P4O6 on the right, and I have a coefficient of 1 already for P4O6 on the right. I'm not going to worry about the states. None of these chemicals change states between the target and the given reactions. P4O6, and I do copy the delta H. For B prime, I have to bring P4O10 to the left, so I'm reversing this reaction, carefully copying it, but in the reverse direction. And because I reversed B to get B prime, I am going to take the opposite sign of its delta H. Now, in the previous video, I literally added everything on the left and added everything to the right, and then I canceled. Well, we could take a little bit of a shortcut and just cancel here, which is what I usually do if it's pretty obvious. P4 cancels, and then we have 302 on the left and 502 on the right. So all of these 302 on the left go away, and we are left over with 202. Since I'm not rewriting this and canceling out under the line, what we can do is we can circle everything that's left over and realize that those chemicals are in the target, in the right side and the right coefficient. If by adding the two reactions gives you the target, then all you need to do is add up the two manipulated enthalpies, or delta H's. 1649.1 plus 2940.1 equals 1291. Let's go ahead and put 0 for 5 significant figures. Make sure for the greater you have the units. Yeah, kilojoules per mole, and make sure you circle your answer. Yes, this was pretty fast. I could have done this on the previous video, I now realize, but not example 2. Confession, I started this video, and when I got started this video half an hour ago, and when I tried to do this problem on the fly, I totally bombed. So let me show you where the hiccup was and how I resolved that. First of all, we're taking diamond, carbon that's in the form of diamond, and converting it to graphite. Actually, that happens over time, plenty of time actually. You'll turn diamond into a piece of coal. But it's very, very slow, obviously, and I'm curious about the delta H, whether it's endothermic or exothermic. The trick, again, is to label your individual reactions because we're going to manipulate them. And the first manipulation is not a manipulation. We're just going to copy C diamond. Now, it is a little bit intimidating because we have carbon on each side of the reaction, one in the diamond form and the other in graphite, and that's it. So why do we have so many, 4 individual steps? Okay. Eventually, all of these other compounds have to cancel out. But let me take care of this first reaction, A. Again, I am not worried about the states because they don't actually change for any individual compound. And my delta H is 395.4. Okay, the diamond part was easy. Can you see why? Oh, by the way, again, maybe you could challenge yourself. Maybe you could prove that you're much better than I am at this. Pause the video, give it a go. For me, it was definitely trial and error. I ran into a couple of dead ends because I had to guess actually. I'm not sure if anyone out there can do this without taking a educated guess as to what manipulation to do, but I took a guess and it dead end and I started over again. Okay, what is the issue? The issue is we have one graphite for C, one graphite for D. If I add them up now, they're going to cancel out and they have no graphite. If I reverse one of them and not the other, I'll have 2 graphites on one side and none on the other side. I'm not able to get 1 graphite. That suggests to me that because of this, I'm going to have to multiply one of these by 2 and then cancel out the other when I add them. For instance, if I multiply D by 2, if I just add C and D, the graphite on the left cancels out on the reactants, and I'm left over with 1 graphite molecule on the right. Okay. The thing for me is that if I multiply D by 2, I'm going to get 4CO, and I don't know if I could actually cancel out that 4CO. It seems like I would have to do a lot of other manipulations for the other reactions. On a leap of faith, I'm going to double C, but then do you realize that I have to reverse it to get the 2 graphites on the right, and I'm going to have to reverse this to get 1 graphite on the left. Now, was that my initial guess? No. My initial guess was I actually tried to divide by 2 this one. And I think some of you out there are laughing at me because that would not help because it would just make things so complicated. I would have half a graphite molecule. That means that the other side would have to have 3 halves to be left over with 1. So again, the strategy is, and it's a guess initially, is to multiply this by 2 and reverse. For me, I have to take a guess and then see if I could resolve it and work it out. And if it doesn't work out after, 5 minutes or realizing that it's never going to work out, then I'll try something else. But let me try this, C prime. So I'm going to try to do both of these manipulations on the fly. I'm going to reverse and then multiply by 2. So I'm going to have 2 CO2 going to 2 C graphite plus 2 O2. Yeah, initially my head was spinning because I have CO2s, I have COs, I have O2s. All of those have to cancel out. The other thing is that, let's take a look at O2. I have O2 here, O2 here, and O2 here. I have an odd number of O2. So even if I reverse one of the reactions, I'm always going to have an excess of O2 on one of the sides. I need an even number so they cancel out. That also indicates to me that one of these reactions, A, B, or C, should be multiplied by 2, and then there's a way that I could get 2 on one side and 2 on the other, and then cancel those out because I have a total of 4 O2. You see sort of why this here is, what color do I want to use? This here is kind of a tip, because I could never cancel those O2s out unless I have an even number. Okay, same thing. Am I going to say same thing for CO2? There's 2 CO2. There's a CO2 there. There's a CO2 there. There's a CO2 there. So I have 5 CO2s. Again, an odd number. They would never be able to cancel out. I need an even number of CO2s. Maybe 3 on one side, 3 on the other. Or, well, yeah, if I get up to 6 CO2s. Okay, I know I've talked a lot. Let's not forget that what I did was I reversed and I multiplied by 2. So this one I will reverse and get the opposite sign and then times it by 2. Okay. This is reaction C, 393.5. So I took the opposite sign because I reversed. And then because I multiplied all the coefficients by 2, I also multiply the H by 2, delta H, plus 787. Okay. What that means is that I am going to stick to my guns, and I'm going to keep the 2C graphite on the right. To cancel out one of them, to get 1C graphite on the right, I would have to manipulate D now and reverse that. Because I want to reduce this to 1. C graphite plus CO2 goes to 2CO. All I did was reverse. I didn't multiply reaction D by any number. 172.5, so positive. Positive. Why does this turn out? Oh, it turned out to have no decimal because I multiplied by 2. Okay. Next, well, I'm happy so far now, or I'm optimistic because I have C diamond on the left, and when these cancel out, I'll be left over with C graphite on the right, 1C graphite on the right. It's B now that we may have to manipulate to try to get rid of all this other junk. So let's focus on CO2. We have a CO2 here, 2 CO2, we have 1 here, and we have 1 on the left here. So we have a total of 3 on the left and 1 on the right. So I'm hoping that I could get 2 CO2s on the right to cancel the CO2s on the left. You see how the 2 CO2s on the left? If I kept it as is, I will have 2 plus 2 plus 1, that's 5. Let me reverse this and keep the coefficients. So all I'm doing is reversing. You see what that does for me? I have 3 CO2s on the right, and then there we go. I have 3 CO2s on the left, and those will cancel out. Remember that I reversed it. So this will become negative 566. Let us cross our fingers that everything cancels out properly. The thing is, when you have all the products and all the reactants balanced and on the right side with the correct coefficients, everything else should fall into place, right? For us, it was the difficulty of getting the graphite to work out. But once that's worked out, we should have faith that everything else will work out. Once you figure out, what to do with this reaction, right? This is the one reaction that had neither the product nor the reactant. Okay, enough talking. Let us do the same shortcut by canceling out what we see here. We're using all 4 reactions. Okay, let's start with the O2. There's an O2 on the left and an O2 here on the left. And we have 2 O2 here on the right. O2, O2, cancel out these O2s. CO2 on the right, 2 CO2s on the left, another CO2 on the left, but 2 CO2s on the right. So these CO2s, 3 CO2s on the right, are canceled out by these 3 CO2s on the left. 2CO, 2CO, I like that. And then circle everything that you think is left over, but we have a graphite on the left, 2 graphites on the right. So this graphite gets all canceled out, and we're left with 1 graphite, so I'll just cross out the 2. That's left over, that's left over, everything else got crossed out. Because we added these 4-step reactions, or individual step reactions, and we got the target reaction, you have to add up the 4 delta H's of those 4 reactions that you added. Right? Even though we canceled out everything here, you're using it because we had to add this reaction. You have to add this enthalpy as well. So the curiosity was, is this endothermic or exothermic? It is spontaneous. It just takes a very long time. Double check my work. Oh. It's almost 0. Negative 1.9. I'm going to add 2 more sig figs. Kilojoules per mole. It is slightly exothermic. That's interesting. Okay. Double check my math again. 77 plus 172.5 minus 566. Okay. Negative 1.90 kilojoules per mole. Probably this is the most difficult Hess law problem that I have seen ever. And chances are any Hess law problem that you see on the exam is probably going to be easier. All right. But again, for me, this was trial and error. You just didn't see all the dead ends that I ran into. Okay, good luck. We will be moving on to the next topic in the next video.